stuff. He was supposed to be back Sunday night. Well, he has a layover because he's coming from Tennessee. So his first flight got super delayed to a week next flight. So he had to cancel that or something and did it Monday, yesterday. But he flew in and I guess it got delayed or something again and he got stuck in Texas. So now I think he's still in Texas and he's got to wait until he can catch another flight. It's not a super bad place, but when he's missing his glasses, yeah, probably not leaving there. Maybe yeah. Like, just, he would do, he would like, I don't know. Usually like
What's a nose?
I don't know. It's like an hour.
Oh, I see.
And it's a butt chin.
You gave him a budget?
Yeah.
Why is it not recording till under his mouth? Is he looking to the side like a face profile kind of?
Driving back here, I got stuck in the line. So 1 p.m. on Saturday because it was 30 degrees and 48 miles an hour.
You look like a budget.
I ran out of hair.
I mean, I'm lucky to have
Okay, so let's go ahead and jump into some phasor math.
Is that like a potato wedge with a face?
I am using the bathroom actually. This lecture is brought to you by Depends. Okay. Dang it.
He's revealed his.
Yeah, we've been watching you try to figure out your bathroom secrets. Oh, thank you. Oh man, how much class do I waste just saying the dumbest things? Enough. All right. So here I'm just generally going to follow a book example. We're going to add some phasors together. So here we'll have voltage of one component, and we'll say that this is equal to 3.2 times sine of omega t plus, I don't know, 30 degrees. And then we'll say that V2 is equal to 1.8 cosine of omega t plus, I don't know, we'll also say 30 degrees, because why not? So the question is, what is V1 plus V2? Okay. Well, if you go look at the principles of adding sinusoids, it ends up being kind of gross because you have to use Euler's formula. Okay, so when we use Euler's formula, that is Euler. What? Euler. Euler's day off. Yeah.
All the stuff we're learning today going to be on the test.
No.
But it's going to be on the final.
They will be on the final test.
Which is
the second test.
on the final day.
No.
It's not on the final.
No.
Finals is a pizza party.
I wish.
Can we do that?
We could.
And watch finish early and do a pizza party.
Pizza party, let's give it up. It's fun to watch the Blitz game out.
No, I have a different thing that we're going to do on finals day that I've done every year. No! Although ice cream party sounds even better than a pizza party. Why not both? Yeah. Huh?
A big old lot to spend.
No, you guys want to get your butts kicked? I'll kick your butt. I am reigning champion supreme of Smash Bros. Okay, so looking at Euler's formula, what we have here is that Euler's formula states that cosine of theta is equal to r times, well, nah, I'm going to use the term C1. E to the j theta, okay? Which is equal to C1 times cosine theta plus j sine theta. Okay? So that's Euler's formula. So if we take Euler's formula and plug that in here, what does that mean? Well, it means that we can represent these sinusoids as Eulerian formulas. Okay? So when I do that, we can look up at this and say, all right, okay, 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 oh, okay. Oh, dang, no. This is actually, my bad. That wasn't a constant.
So what's that? That's R.
That is an R that says it's real.
Whoa.
Yep. I have that tattooed on my arm. Actually, it was a birthmark.
The right side.
Dang it.
Is the right side also R or is it?
Yes, it's also an R. Okay.
The R's we used to have been real.
No, they've been imposters. Dun 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 dun. Sus. Anyways, friggin' meme culture. One summer, my nephew forced me to watch every single possible imposter video ever. He's like, oh, hold on, I got the next really cool video. Oh, it's the exact same one you showed me 5 minutes ago. Jesus.
What's your favorite thing to watch on YouTube?
My favorite, absolute favorite thing to watch on YouTube? Like how it's made videos.
Oh yeah, those are silly.
They're really good.
I approve.
Sometimes I like watching people that, I'm also that nerd. I like watching the professors teach stuff. Yeah, I'm a nerd. And also I like really informative videos, like people talking about Raspberry Pis and people talking about robots, and then I also like watching like Studio C or a BYU comedy group, but I don't really like their older stuff. Some really good videos. We should pop them out over break.
Yeah, when you go home, can you watch How It's Actually Made by Huggies? Like Huggies is the YouTube channel.
Who has a channel called Huggies?
I don't know.
It's an old freakazoid term from the 90s. Yeah. I don't know if he's got the strength to do it. Come on, kids.
They make a bunch of episodes of How It's Actually Made.
You know what you need to do.
You can't watch
Huggies.
it here. You can watch it at home.
Come on, he needs it from you. Huggies. Huggies!
He's having nostalgia.
Nostalgia moment. Okay, so anyways, now what this says is that we're only taking the real component from this piece of the equation. That's what the R means, okay? I don't want anything that isn't real. And here, this piece right here is not real. Okay, J sine, that's not real because it's got a J in it. Okay? Anything with a J is not real.
So what happens when you multiply the not-real E with the real R?
Well, it only takes the real components from here. Everything else sits in the imaginary realm. So here, a cosine wave is both a cosine wave and a sine wave. However, the sine wave exists perpendicular to the cosine wave, but only in the imaginary realm.
I think Euler is just a brain.
Euler was whack. That man was a genius.
So that's pretty much saying cosine theta equals cosine theta.
Yeah, it is. That's what it boils down to. But it adds to the fact that there is an imaginary sinusoidal component that also goes along with it. Whereas r cosine theta and j sine theta are actually plotted very differently. So r cosine theta exists only in this axis, and j sine of theta only exists in this axis because this is the j versus r axes. They're actually perpendicular components. Okay, so that's what that means. Now we can take Euler's formula and we can break this down. I'm just going to go ahead and write this in its real component. So this is equal to 3.2 times the real form of e to the j times omega t plus 30 degrees. Although we have to convert this into a cosine function, I guess, but whatever. Do we?
So we just subtract it.
So sine in terms of cosine, sine is cosine plus 90 degrees? Cosine minus 90 degrees? There we go. And then this is equal to 1.8 times the real component of e to the j omega t plus 30 degrees. Okay? So all I've done is I've just rewritten this in a new format. Okay? And then we could take this, and then when we go to add these, what we're adding is we're adding the real components of the Eulerian piece of the sinusoids. Okay? So V1 plus V2 is equal to 3.2 times the real component E j omega t minus 60 plus 1.8 times the real component of E to the j omega t plus 30 degrees. Okay? Now, if you know anything about anything, nerds, you can actually split this out into different components. Okay, so it turns out, again, we're just playing with a lot of fun math here. E to the A1 plus A2 is equal to e to the A1 times e to the A2. Okay? So we can actually use this because we have a j omega t in all of this. So this is equal to e to the j omega t times 3.2 times the real component of e to the j times negative 60 degrees plus 1.8 times the real component of e to the j times 30 degrees. Okay? This is a derivation, so you'll probably never do this. All right, so I'm actually just going to leave the j omega t out there. And then what we're doing is we're just adding this and then that. And then that's it. Okay, so we are going to look at this. We are actually going to break this component out into, this is two pieces. So here, e to the j times a1 is equal to I'm just making sure I'm doing this right. Right. Is equal to cosine of a1 plus j sine a1. Okay? So as we go to break this back out, what this component ends up being is it equals e to the j omega t times 3.2 times cosine of 60 degrees, and that's a negative 60 degrees, plus 3.2 times j sine negative 60 degrees. Okay? So that's the first piece. And then we have the second piece plus 1.8 cosine 30 degrees plus 1.8 j sine 30 degrees. Okay? And then end parenthesis. So here, this component right here is this one right here. And this component right here is this one right here. So I just expanded them using Eulerian's formula again, the Euler's formula. Okay, now, just like adding perpendicular components, you have an I plus I, j plus j. So what we end up doing is we add the i's and we add the j's. Or here, we add the real components and we add the imaginary components. Okay? Just like a utopian society. You add the real components, you add the imaginary components. I won't say what I was about to say there because I have Russian viewers. That's terrible.
Just one more.
Why does he keep talking about socialism? I don't understand. It is great style of living. We need to inspire the Western world rather than listening to a stupid professor. I throw a link in the leave. Anyways, so we're going to go ahead and calculate all of these components out. So what is 3.2 times cosine of negative 60 degrees? Okay.
Square root of 3 over 2.
Yeah, negative.
Just take it be positive.
You don't like radical? Radical 3 over 2. Radical.
Radical. So this is equal to e to the j omega t times 1.6 plus
Radical.
radical. Drink it. That was a SpongeBob quote. Radical. Radical. Drink it. So this becomes 1.6 minus 2.7713j. That's this piece here. Plus, and then you have a 1.8 cosine 30 degrees, which is 1.5588 plus, and this is going to be a 0.9 J. So that's that component, that's this component. Now what we'll do is we'll add the J's together, and we'll add the non-J's together. So everyone who's a J, go to that corner of the room. Everyone who's not a J, who's a real person, go over there. Do we have anybody else whose name starts with a J in here? Get over there. No, yes, okay, you're over there. You don't belong here, man. Go to the real side.
I'm real.
Real boy. Kind of threw me off with the whole, like, is it a Z? Is it a J? Could it be both? Is it both simultaneously? You're both real and not real. What's wrong with you?
Is it a Z and a J?
Yeah, it is. It actually just looks like this. There it is. That's how he writes his name. And then it's,
Oh, I like where this is going. Now you have to finish it. Now you have to. Okay. You got it. Wait, I know.
Nope. How do you write an N that also looks like a K?
Just like do regular N with the little thing, like at the top. And then like, look, end of the K power, I like it. That works.
I don't know. Bro, I did 3/4 the work for you.
You could write it like a cursive R with the line on the left.
I'm like,
That worked.
and then.
Well, now I just feel like I've been lied to about the name.
I should start using
Actually, yeah. I actually, well, no, because which one is it? This could be Jack. Huh? Huh? Did you think about that? Or, yeah. Nope. It could also be Zuck.
It's a robot.
I'm so sorry. I'm so sorry, Zach. Oh. Man, I don't know what's wrong with me today. Zwack. Zwack, bro. All right. So all we're going to do is we're going to add the real components and the imaginary components. Okay? So this ends up being, oh, I need more board space. I have more board space. So this ends up being e to the j omega t times 3.1588.
Oh, what a letdown.
What?
1.4, we had pi right there.
Wait, isn't it Pi Day?
Today's
Dang.
3.15. There was free pie yesterday, but you don't like pie.
Oh, I had pie yesterday.
There was free pie.
That explains everything. Minus 1.8713J. Okay? So, all I did was I combined terms. Now, when I'm looking at this, if you want to find out what this is equal to, what you have to do is you have to take the inverse cosine of 3.1588. Yeah.
Oh wait, never mind, I lied.
Stop lying.
Keep going.
Negative 1.8713 divided by 3.1588. And if you take the inverse cosine of that, wait, no, inverse tangent of that, I should say. Flip.
Negative 30.
Is that what it is equal to?
Yeah. Negative 30 is
Five kids like a point on the test.
Okay. And then we also take the square root of 3.1588 squared plus negative 1.8713 squared. What is that? It's been a whole year since I've even thought about this. All right, so this is equal to 3.6715, okay? So we can then write this as this is 3.6715 times cosine of omega t minus 30.64 degrees, okay? That was kind of gross. But this is the process that we go through to add two sinusoids together, okay? Now, let's do this again, but this time let's use phasors, okay? It cuts out the middleman of having to use j omega, which is kind of gross. We skip a whole bunch of this like, what the heck is that? And then we just focus on phasor math, okay? So I'm gonna give you two other sinusoids. We'll add them together, and then we give you one more, and then you'll do that on your own. And then we'll come back together as a group, talk about the answer, have a break.
Kit Kat break.
Huh?
Kit Kat break.
Nah. Nah.
Are you
Hater? Yes.
do you eat just Kit Kat at a time, or like do you just bite the Kit Kat?
Oh, what? What chaotic evil there?
Some people do it. They just
No, monsters do it. You have to break it off one at a time. Like in a nutty bar, you actually have to like eat each layer independently.
It's instead of splitting one off, they go split part of it.
So I feel like the best part of like a nutty bar is just pulling it apart, not actually.
And then you lick out the peanut butter. Yeah, it's pretty great. All right, so this time we're gonna do it in phasor style. We're gonna be doing the exact same math that we just did, but we're gonna represent it with phasors. And as a result, we're gonna skip all of that e to the j omega crap, okay? I did, but I do that all the time, so. Oh, snap. All right, so we'll say that this is 5.3 sine omega t plus 16 degrees, and then this will be 4.8 sine omega t minus 70. Oh!
You want to translate that?
Oh man, they retracted one of their messages. Dang, it's not even a link.
It's actually words.
What if he has like actual feedback? Put it in Google Translate.
I'm trying. It's not working.
Oh, you already
It doesn't
tried?
let me. It won't let me.
Well, let you copy.
It says report. That's the only thing it says.
It translates to me.
Oh, he said something else. He said. He put a question mark up and said, "Yes, your question."
He's asking a question. Say yes.
Hold on, I can copy and paste this.
Okay.
Copy. All right, Google Translate.
It's good fun.
Yeah.
Like we said, there's something to do to you right now.
can I come to America and marry you and to get a green card?
Wait, actually? I come to America and marry you so I can get a green card.
That was the second question. The first one was, this is so interesting and you were so beautiful.
It must be American.
The person's name is Olga.
Hello. Hello. Hi.
Can you put on makeup for Thursday?
No. Why do you hate me? Okay. Anyways, so what we're gonna do to start out is we're just gonna man.
It's a woman.
I don't know. Could be a man.
Olga is
We're just gonna represent this as a phasor. So this is gonna be 5.3 angle 16 degrees. To convert from a sine curve into a cosine curve, we have to subtract 90 degrees. Or maybe we just leave it as a sine curve. That sounds more fun. Nah, we gotta convert it into a cosine curve. Is this plus or minus?
plus. I think it's.
I think it's minus. Did we do a minus on the last one?
Yeah, it's on mine.
All right. So then this is,
Would it just be off by a?
I don't actually know. I don't want to find out. So,
Wouldn't it be just a sign? Like a positive or negative?
I don't know. In any case, just rewriting this. Angle of negative 74 degrees. 4.8. Angle of negative 163 degrees. Okay, that's fun. All right, so what we do in order to add these, V1 plus V2 is equal to 5.3 angle negative 74 degrees plus 4.8 angle negative 163 degrees, okay? We're gonna again break this into two components. This is 5.3 cosine negative 74 plus 5.3 negative sine negative 74 times j. So this is equal to 5.3 cosine negative 74 degrees plus 5.3 j sine negative 74 degrees plus 4.8 cosine negative 163 degrees plus 4.8 j sine negative 163 degrees, okay? Now, once again, we're going to figure out these numbers, and then we're going to add the imaginary components, the real components, and then we'll convert it back into a sine wave, okay? That's all we're doing here. But this is the first time, like, they were actual real comments.
Yeah.
Makes me wonder if it's not just one of you. And no, I won't marry any of you. $1.4609 plus minus 5.0947 plus that's minus 4.5903 minus 1.4, oh, and there's a J here. 034J. Okay. So now we add the real components, we add the imaginary components. This is equal to negative 3.1294. Shut up!
His accent was on point.
It really was.
Ah, dang it. Post that on YouTube. Again, I'm glad your sister was not here. You ring them, shut up! Shut up! That's so bad. Okay, so here's the result we get. The next piece is, I don't think I explained this very well at all. What this represents is that we have a vector that has a real component and an imaginary component. That real component extends negative 3.1294 in this direction. The imaginary component extends negative 6.4981 in this direction. So we have a phasor, and our phasor is actually represented by a line that is a magnitude here, and some angle phi. Okay, so that's really what we're doing here. Do you want to slightly easier? So this is what we're doing. We need to calculate the magnitude of the line, and then we need to calculate phi of that line. So the magnitude is equal to the square root of both of them squared. Which that's equal to, it's the first time in my life I've ever been proposed to. Nice response, Duncan.
Something in Russian.
I'm gonna have to translate that before the end of class. Yeah, otherwise things are gonna get real awkward.
Could be. There's something random like I like fish or something. Huh? If it doesn't translate back, I'll do something like I like fish. Oh, that'd be sick.
So this is equal to 7.212.
Look her up right now.
Like, it's that super muscular Russian woman. Like, oh, this is very interesting. More testosterone than you do. Oh, thanks.
Might not have a choice.
I'm okay.
Yeah.
Okay, and then here, phase angle is equal to the inverse tangent of the J component, which is negative 6.4981, divided by the real component, which is negative 3.1294. Now, you will get one that's in either quadrant 1 or 4, so you'll just have to add 180 degrees to that to get the real phase angle. 4.981. So this is, the answer to that is equal to 64.285 degrees, but we have to add 180 to that. So it actually ends up being 244.285 degrees. So the answer to this is 7.212 angle 244.3 degrees, okay? And so that's the answer. Okay, there's a lot of math involved, not gonna lie here. This is not exactly easy.
And so why'd you add 180?
It's because both of these are negative. So we know that the vector is in this direction, but the answer we got was in that direction.
You have to flip
gave us the right
angle sign around when the phase angle is smaller than the magnitude, right? Pac-Man always faces the bigger number.
Sure. All right, so what I'm going to do is I'm going to give you two angles, and I'm just going to give you the phasors straight up, and I want you guys to do the math. And once you've done the math, we'll come together as a group, we'll take a break, and we'll get started talking about why this is relevant. All right, add those two phasors up. V1 is equal to 15, angle 45 degrees. V2 is equal to 20, angle 30 degrees. I'm going to show up the live stream. I'll show the answer at the beginning of the next one.
Wait, can you copy and paste what that says?
Yeah, we got to find out what Duncan said before that.
I hope it translates back correctly.
We can hope. If you called me beautiful too, things are going to get weird. I ride a camel to school every day to get an education.